morning. My name is Claudio Silva. I'm a professor at NYU. My slides, I have 3 slides, and then I have that are the most boring visualization slides you're going to see because I just responded to the questions, and I'm going to try to talk to them. And I put some eye candy in the end. As visualization people, we do all kinds of that work. But you can look through these websites for work that we do. So my background is as a computer scientist and in applied mathematics. So as I go around the room here, I see many people that that spend time at the same places I did. I spent 7 years at Stony Brook between the computer science department and the applied math department, and 8 years at Utah. And it's been it's just wonderful just to see how many. I mean, it's a big privilege to have worked at those places there, and also. The rest of the time was divided between working for DOE and working in industrial research. So I've had experience with that before returning to academia. My work has ranged in all the way from visualization algorithms. At one point, speed was a big problem. Right? I would say that now, as I think Jeff mentioned this and Ken, we're really good at doing things with speed, right? And we know how to do a lot of that stuff. To building systems, sometimes very large-scale systems like these trails, very general, to very specific systems like BirdVis and other systems like UVCDAT that actually are just being deployed by DOE now. To evaluation work, I would say that I'm one of these people. I started my life doing scientific visualization, but I truly fell in love with the human, right? So I think that Ben really caught me, and I'm more and more, I'm just so, much more interested in what it means in the end for the human. I think that the technology side of making things scalable and all that stuff, we understand very well. So my current research focus, as you guys are going to see, is mostly in urban data analysis, and there's also a lot of work in climate data analysis in the context of UVCDAT. So what am I passionate about? So I try to sum it up in one sentence. So I would like to substantially improve how users and scientists, for the most part, can I increase their productivity in doing data-driven discovery by designing tools and letting. I take tools here to actually mean something very broad, right? So software is tools, new methods tools, the new mathematics is also tools, right? And new concepts and paradigms, things like tree map, is also a tool, right? And I want to build these things so that it helps them to explore and understand their data better, right? So that's really what I'm passionate about. And I don't care if at one point in time I'm spending most of my time hacking software, and at another point in time I'm proving theorems, right? It's just incidental to the work that I'm trying to do at the time. And actually, some of the examples I have, if I get to them, they have these components, and you guys can take a look at the papers. So what are the current challenges in our work right now? I would say that, I thought long and hard about this. I was like, can I summarize this in a short slide? I would say one of the first things is just usability. I think that the visualization community has been really good at developing tools for viz people, right? We have not really been good to develop tools that are used by other people. And I think that this is a big problem. I really think we need to develop a tool. So I don't call something a tool that one of my students has to use it for you, okay? That's not a tool. A tool is something that I can give to you and you use it, right? And there's no way that I'm going to become an expert. So right now I'm doing all this data, in the concept of the Center for Urban Science and Progress at NYU. We're doing all this work with New York City, right? I'm not going to become a traffic expert, right? I know a little bit more about traffic now than I did before, but I have to be able to give this tool. For instance, the tools we're developing, they are actually deployed by the Department of Transportation in the Taxi and Limousine Commission, right? The fact that they can use the tools, that's what it means that a tool exists, right? The other thing that is very important, and this is on the other side of things, is actually on the theorem side of things, is I want to ensure correctness and effectiveness of techniques. And I would point to Thiago Etienne's thesis and Eric Anderson's thesis from Utah. They were both my PhD students there. It's beautiful mathematical work in Thiago's case, and beautiful usability work on Eric's case that I think really shows you how to do these things. And I'll talk a little bit about Thiago's work later, right? The other thing that we are really lacking, I think, is integration of visualization with other areas. So if we are doing visualization of data and we cannot integrate with data management systems, okay, there's a problem there, right? There's a serious problem that I cannot, so I think that we need to work with these communities to enable, interoperability of our techniques. So there are huge gaps between us and these other communities, right? And finally, I would say that what is another real challenge in my line of work is develop sustainable, usable, and open software, right? This is huge. So what's on my wish list? Move the needle on urban data analysis. Most of my work has been on this. Enable reproducible data-driven discovery. Educate scientists, right? And contribute to open source and widely used tools for support and analytics. So let me show you a little bit of eye candy here. So this is TaxiVis. This allows now the taxi and limousine in New York to visualize close to 1 billion trips between 2009 and 2013, right, in real time. And they could never do this. You can slice and dice the data any way you want. There's all kinds of very interesting features on this. I want to show you this, although Thiago's work, and I hope people go and look at his thesis, is on how do you know that your algorithm is actually doing what you're supposed to? You wrote a volume renderer. How do you know that that image is actually the right image, right? So right now what people do, let's say what Kitware does, is that it does a regression test. At some point a human looked at an image and said, it's a good image, right? Okay, this is the right image. And then from that point on, that is the definition of correctness, right? Would it surprise you that Thiago, using his techniques, found bugs in VTK that has been there potentially maybe for 10 years or so, okay? And that, you couldn't otherwise do without actually proving theorems, okay? And then you can say, these are half a millimeter, yeah, anyway. So just look it up,